Hi guys, and welcome to another unboxing video. I've been and bought some stuff again, and we're going to take a quick look at it. So let's get straight into it. So what we have here, if I remove some of the parts, you can see some SMA cables, some SMA plugs, and in here is the actual device itself. So what this is a NanoVNA version 2. Now what this is a Vector Network Analyser, where the name comes from, which basically you can use to test antennas, that sort of thing. I have to admit 100% I'm very much a newbie with this, but I've been interested in getting one of these devices since I saw Pavel Spahowski's video on his big black network vector analyzer, which it was a cheap unit from, well, I say cheap, it was about 130 pounds from Banggood, and at the time I couldn't justify that sort of thing. And later on, you obviously watch YouTube videos, that sort of things, and people were going on about this NanoVNA product, and I saw videos with ham enthusiasts with £1,000 VNAs, and it was really close to their high spec, high end machines. So for a hobby grade thing, it's really accurate for hobby grade. The problem with the original VNA or NanoVNA is that it went to about 900 megahertz. This one here, the version 2, goes from, I believe it's around 50 kilohertz all the way up to 3 gigahertz. So for RC hobbies, we've got the 433 megahertz, we've got 900 megahertz, we've got 1.3 gigahertz, we've got the 2.4 stuff. The only thing it doesn't really cover is the 5.8 gigahertz stuff, but everything else you can actually check out and potentially tune using this little device here. So I admit I've had a quick play, but let's cover what's in the box first. So you get the unit itself, as I mentioned. You get 2 SMA cables, which seem fairly decent quality. I mean, they're probably nowhere near the high end stuff, but it's not ultra thin cable. I guess it's around the 316 RG316 sort of thickness, but there's no indicators on there to say what it is. But you get 2 of those, and they're about 30 centimeters each. You get this bag here, which is what you use to set this up, because you calibrate it. So we'll go into that later. And this plastic bit here with all these extra bits is just a case. And I believe those screws are just to screw the case together. But we'll put the case to the side and we'll just look at the interesting bit for the minute. So it could be powered by USB. So on the bottom you have the USB port. You can use this to power it. I don't know if there's firmware upgrades, but I'd imagine if there are, you can do it there. You've got an on and off switch on the side. You have the 2, I don't know if they're just receivers or transmitters as well, but whatever the RF stuff that this does, you have that in there. There's also, if you can see inside, there's other shielded components. So it looks like there's 4 main RF components. You have the 2 SMA plugs on the top. Actually, it's the bottom, but you can turn the screen round to if you want it to be the top. And then you have the 3 buttons to operate it. And what you also get, which is in the bag still, is a stylus, because it's touchscreen. Alright, so a slight change of plan. I thought I'd actually build it into the case, so I might as well review the case while we're at it. So it's okay. You need to take out the small screws from the top and bottom of the circuit board and replace them with the longer screws in the packet. You also need to undo the nuts on the SMA connectors, take those off, and then slide this piece on first. You may find that you need to slide or screw in the inner nuts a bit more so you can actually get the buttons to protrude, which isn't so bad. Once you've taken the inner screws off, the screen part just slides off. So it makes, if you wanted to put a battery in, which inside there is a plug for a battery, there's no charging circuit inside this, but they recommend a 1000 milliamp hour to 1800 milliamp hour 1S lithium battery. So it could be lithium ion, it could be lithium polymer, but there's no way of charging it built into this. So you'd need to take it out and charge it, which that's a bit of a pain in the arse. So I'd probably just power it from the USB using some sort of external power supply, like a power box or something that's easier to charge than taking this apart to take a battery out. So yeah, so that's the case. It does actually protect it quite nicely. It's a softish plastic. The only other thing I would have said, it would have been nice if there was some spaces between those screws and the plastic, and the same on the bottom, because when you screw it up tight it bows this slightly. So I may 3D print something. I'll stick an STL up somewhere. As you can see, it's not the with the case done up, it's where it bows, it's not the straightest thing, but you could always put a foam pad on the bottom or something like that to stand it on. Right, so let's get it plugged in. So will the USB fit through the hole? There we go. We've got lights, and then we've got the power switch on the side, which again is really flush with that panel, so it's a shame it's a bit inset. Right, so this is our basic display. As you can see, at the moment it is upside down, so if we go into display we can do flip, and then the antennas and the buttons, unfortunately, at the top. It would have been nicer if the buttons were the opposite side to the antenna, so when you're going to press the buttons you're not accidentally touching the antenna, that sort of thing. I know on my camera that is looking really bright, but in person it's actually a really nice display, and I can get a good view of it with quite a wide angle, and you can, if I tilt it there, you can just about see the wording. I mean even that now still looks crap on the camera to how it looks in person. It's really clear, so the display itself is brilliant. Right, so what we need to do, the first thing we need to do is calibrate it. So what we need to do is actually the first thing we need to do is click on the cal button and then go to reset, which will reset the calibration. Now what we want to do is add on our SMA extensions. So the second side is optional, but I'm going to do it anyway. You'd mainly use the second side, I believe, if you're testing stuff like adapters. So if you had an SMA to RPSMA, you'd put that together onto this to test the adapter itself. So what we have in our little kit is we have what looks like 3 blanks or 3 terminating connectors, and this straight connector here, which basically what that does, it's just an SMA male to SMA male adapter. So there's a hole in each end, so the pins can go in each end. So what we need to do is put that into here. So now we can screw our SMA male, these are our calibration keys, I believe they're called. And the first thing that we need to do is use this one here, which you can see in the inside it's completely empty. So this is what's called the open, so it's an open circuit. So we'll screw that on. Obviously get our hands off of that, and then we'll click on calibrate and then click on open, which I don't think you'll be able to see, but the whole lot, the text turns green when it's doing the calibration, and then when it's finished, it's hard to see. I'm sorry about that, but the word open is now in white, and it has a black box around it to show that it's done. Everything else, the text is in black on the white background. So the open has been calibrated. So we take that off. That's done. The next one we want is this one here, which you can see inside. It's basically just an SMA adapter, but the whole thing is metal, so it's a short. So if you put a multimeter on the pin and on the outside case, it will show that it's in circuit. It's shorting out the signal. So we'll screw that on, and then we'll click on short. Again, it's gone green. When it goes black box around the word short in white, it's finished. So we can take that off. And then the final one is this here, which is a load. I don't know how many ohms this load is. Usually they're about 50, but I don't actually know what this load is going to be. So we'll put that on, click on load, goes green, goes black box around it. So that's that. We could actually end it now, but you can also, as I say, if we're calibrating connectors, we need to calibrate both cables. So screw the other cable onto there, and then click on through. It will go green, black box around it, same process, and then we can click done, and then you can save that calibration. I believe I read somewhere that you need to recalibrate it every time that you want to use it, just to be the most accurate. So that's our calibration done, so we can take that off. I'm actually going to take this cable off because I'm not going to use it. And as I say, I'm completely new to this, so I don't know exactly how it works. But I know we can test antennas, and we have things like the standing wave ratio, which we can test. So I'm going to stick on this. This is a 2.4 antenna. Actually, it's not going to work because that's an RPSMA. This is off of my Tyrannus. So I have here an SMA adapter. Now I believe if we put another, so this is RPSMA to SMA. So if we had another one which was SMA to RPSMA, we could put that in line with that cable, and I believe we can check the loss through this. I don't know that yet. But if we do, we could see, you know, the difference the adapter makes compared to what just the antenna makes. So we can put the antenna on now, and what we need to do is set the range. So what I'm going to do, I'm going to have it like this, because I believe it works off of this second SMA here. So I'm going to leave it like this, but I'm just going to stretch it out away from the unit, so it's like that, if you see what I mean. It's just further away, but it should be that it's getting the best signal. So let's get that back in picture. So first thing we need to do, if we go back out of there, what we need to do is click on stimulus and then start, and this is where we set our start range for the frequencies. So this is 2.4, so basically the G, M and K is gigahertz, megahertz and kilohertz, and that's obviously just hertz, because this goes 50 kilohertz up to 3 gigahertz, so it's quite a wide band. So if we go, I don't know what, 2350 megahertz, and then if we stop at 2.6, so we could do 2.6 gigahertz. So this is showing a load of stuff that antenna is providing. So this is all along the top here. So we have our pointers, which it's currently at 2.425 megahertz. So sorry about that. So whatever these charts are doing, which I know the green one is the Smith chart. But yeah, whatever these charts are doing is at 2.54. So this pinky color is the phase. It's got phase at 90 degrees. I don't really know what that means. I'm guessing that this big change here is something, but it's something I need to learn. We're just having a quick look at the product. I don't know what the log mag is, and I don't know. So we got the two different log mags, one at 10 dB, both at 10 dB. Oh, channel 0, which is this one, and channel 1, which is this one. So that's obviously something on there. But what we can do, if we go back, and I have to remember where this is. I think is it in marker? No. Display format. We can put SWR on here, which, if we're looking at antennas, we're more used to seeing that. So it's got SWR 1.0, which is the best that it should be. So right down the bottom is 1.0. The higher up is obviously a higher reading. So at the moment, where the marker is at 2.425, it's at 1.83. So with the buttons on the top, we can actually move. So if we find the low point, which is about here, I don't know if we can tap. No. Oh yeah, we can just drag it with the pointer. That's really handy. So that was the low point in our standing wave ratio, and that is bang on 2.5 gigahertz. And that is a 1.48 standing wave ratio, which isn't brilliant. The closer to 1, the better. So it's not a very well tuned antenna, these rubber duckies. So we could swap this out and potentially get much better signal, much better strength, much better range, just by swapping the antenna on our Tyrannus. Something like a VAS shapeshifter, so you can go from an omni to a long range mode. Something like that would, I'd imagine, be much better tuned than this. And I'm sure other companies such as True RC Canada, all sorts, will have other 2.4 antennas that will work better on a transmitter. So yeah, we can see that one is not very good. So let's, just out of interest, try another antenna. So let's take that off. I know obviously it has got that RPSMA adapter, but I really don't think that's doing much. So let's try the TBS Immortal T. See how that shapes up. So again, what I'm going to do, I'm going to do the same thing. I'm going to put it on the desk like that, so the strongest part of the signal is coming to the antenna. Let's move some stuff out of the way. Oh, that took some doing, because that's quite a long antenna with that extra sort of 50 mil. So yeah, that's the Immortal T. So what we need to do is go back, go stimulus, start. So this one should be tuned to 868. So if we look at, I don't know, 825 megahertz, and then set the stop point to 925 megahertz. So we can see here, this is our standing wave ratio, and it's not looking brilliant. It's all the way down. That's down here, and that's at 833 megahertz, and that's at almost 2. So maybe it's how I've got the antenna. So let's try that. That's better. So The frequency center point is now here. It's about 863. And we're about 1.31, 1.30 on the VSWR. So again, I mean, that says that this isn't great, but this is quite old, so potentially it's maybe damaged. Potentially this could actually not be as accurate as we were hoping. But even so, it will give a good comparison between other antennas. I mean, it's still, so it keeps going down. It's 1.27. So it's still 20 or 0.20 lower than the Free Sky rubber ducky. So 1.2, I guess that's not too bad for VSWR, but 1.4 definitely is. And that's at 863, so that's not far off. I mean, I'm guessing that's going to be in the acceptable range because there are multiple frequencies on and all that sort of stuff. So at 868 exactly, 1.27 still. So that's not bad. That's definitely. So the last thing I want to check is just another frequency antenna. This one I've actually got two antennas the same frequency. I've actually got two antennas, two matching antennas. So this is the 5.8 True RC Singularity. So again, I'm going to stretch that out, try and get that flat on the table. So let's try and get that lead out of the way. So again, we need to change the frequency. So we start at 1.2 G, stop at 1.4 G. That might be quite a big range. So we can see that it's actually down here that it's at its lowest, which is at 1238. So let's change that top end frequency. Yeah, that's better. So now we can move this down to about here where it's dipping, and that's about 12400. And again, the SWR is at 1.28. So again, maybe so it's gone down to 1.25, 1.26. So it's around 1240 where it's advertised at 1280. But again, we don't know how accurate this unit is. There are, hopefully we'll get some videos from proper ham operators that know about this. It's shifted just by moving the antenna a bit. So where is it now? That's close to the 1250 and at 1.13 SWR. So maybe it's just my positioning of the antenna. If I tilt it slightly, the problem is you get your hand in it, and as soon as you touch it, it's obviously interfering. But that's at 1.15, so that's not bad. And it's 1250. So the last ones I'm going to check, and again this is just purely for comparison, is I have this antenna here, which is the VAS dipole. And the reason I want to test this is this is how they come from in the packet. And I actually spoke with IB Crazy and asked if I can reduce the length of it, whether it will mess with the tune. And he said, so long as it's, I can't remember the exact measurement, so long as it's at least that length or between two lengths, it will be fine. So I've done that. Now I just want to, now I've got something I can compare against. So this has got quite a long lead on it. So I don't know how well this is going to work, and I don't know which orientation is going to be best for it. So if I put it like that, so at the moment it's sort of on the vertical. better on the flat. No. Right, so if I hold it there, I can hold the other one in the same sort of position. So as soon as you get your hand near it, it does affect it, because you're changing the ground plane, I guess. Right, so what I'm going to do is put something on my desk so I know exactly where I'm holding it, because the other one's got a shorter lead, so at least we can sort of compare them. I think that's actually interfering with it. So it could be I've got so much crap on my desk, like I've got a soldering iron just there, and all this is interfering with the antenna. But we'll leave it here just for the minute and see where we go. So if we move, I'm trying to do this left-handed, the marker to the center of that low point. It's shifted again. We're looking around there, so it's around 1260 and around 1.13 on the standing wave, 1.12. So the center has actually moved again, so 1286, and again it's still 1.12 on the standing wave. So now I just want to check the chop and see what this is like, see if I've completely ruined this antenna. I mean, obviously how we'd use this in the real world is if we're making our own dipoles and you can use it to trim to length, that sort of thing. So if I put that here, it's actually, the V-SWA is pretty much the same, but the low point is around here. It keeps shifting slightly, but it seems to be around here more, which is bang on 1280. So if anything, that's actually helped. Oh, the V-SWA's gone down, just gone down to 1.04, 1.03. So maybe shortening that lead was really a good thing. Maybe I'm just moving it slightly. 1.01. So maybe it's where my hand is. If I move my hand a bit further away, still getting 1.04, 1.05, and it's shifted the frequency up a little bit. But the good thing is it looks like the antenna is still good. But as I say, I don't really know what I'm doing with this thing. I know that a low V-SWA is good, and obviously we can check the frequency that it's in. I need to learn about Smith chart and all these other things, but as far as the unit goes, it works. I believe I mentioned earlier that I wanted to get one of these when I saw Pavel's video, and he was using a different type of Vector Network Analyser, which I did look for recently, but it seems like you can't get them anymore. And these, the NanoVNA, the previous model, was actually really highly recommended by a few ham experts that I'd seen, and they said it was really accurate for what it is. Well, actually, not for what it is, they just said it was pretty accurate. So that's why I went for this version 2 model, which can do 50 kilohertz to 3 gigahertz. The other thing is that it's less than half the price of the unit that Pavel showed. This is, if I have a look on Banggood, right now, today, which is the 16th of July, 2020, it's $60. So it's a very cheap unit for checking antennas. And even if it's only comparative, you will still be able to tune your antennas better. But obviously there's a lot of research that needs to come into this. So yeah, all I can't really comment on how accurate it is. I don't have that level of knowledge, and I don't have any high-end stuff to compare it against, but what I can say is it's put together well. There's a few things that could have been better with the case, but overall it works well. The case will protect it. The buttons could have been in a better place. The switch is a nice touch, and the screen is actually really clear. The video is not really doing it justice. So what I'll probably do is I'll take a photo and put that as the video, main image type thing. So maybe you get that blown up. But it's a really nice screen. The touch screen works really well. It's good that you can drag it about because you don't even need to use the buttons. And I believe you can do a lot with this unit. So if I go on that the display and format, so I don't really know what this does, but what you can measure is the log mag, the phase, the delay, Smith chart, standing wave ratio. You got polarize. You got it says polar, so I'm guessing it's polarization. You got linear, real, IMAG, resistance, reactance. So there's a fair few things that you could actually check with this. So I hope you guys find this video useful. I personally, if it was me, well, it is me. I bought this, so I'd rather get this one for 60 quid than paid 130 quid for it, which is again just another amateur level thing. But I believe the original VNA or NanoVNA got better reviews than that other unit for accuracy. So again, if this follows the lineage, if it's as good as its predecessor, then it's going to be a really good unit for the hobby level. So I hope you guys found this useful. I'll put a link in the description to this on Banggood. Thank you guys for watching. Please like and subscribe and all that good stuff, and I'll see you next time where I'll hopefully have something that I know what I'm talking about. But thank you for bearing with me, and I'll see you later. Goodbye.